Hey Math 20-2s, today we're going to look at the sine law. So last lesson we reviewed some trig and right angled triangles using basic primary trig ratios, sine, cosine, and tangent. Next three lessons we're going to focus on solving triangles which are not right angled, and therefore our primary trig ratios, sine, cosine, tangent, are not valid. In the next section we're going to work to determine the side of an acute angle triangle by splitting into two right triangles, and then we can use our primary trig ratios. And in example 2, we're going to use the sine law. So example 1. Triangle ABC has three acute angles. We're going to use primary trig ratios to determine the length of side BC. So work to 3 decimal places and answer to 2 decimal places. Great. Step 1, let's find the length of BD from B to D. So if this angle is a right angle, we know that this side is also a right angle. We've got our two right angle triangles, ABD and ADC. So the trig ratio that starts at 20 degrees, uses opposite and hypotenuse, is called sine law, or sine ratio. So the sine of 20 degrees is opposite the side we're looking for, BD, over the hypotenuse, 12.50 centimeters. All right. Therefore, to solve for BD, we're going to multiply both sides by 12.5. So 12.5 times the sine of 20 will give us side length BD. So do that on your calculators. You find out that BD has a value of 4.275. So work to 3 decimal places, answer to 2. This side length is 4.28 centimeters. Cosine, next step, we want to find the length of AD. All right. So if I figure out that height, then I can use that to find some lengths inside ACD, specifically side CD, so we can add that to side BD and figure out the length we were asked to find in the first place, side BC. All right, so staying with triangle ABD, let's find the length of AD. Again, from the angle we're given, from 20 degrees. This is our adjacent side, this is our hypotenuse. So I will say that the cosine of 20 degrees is length AD over the hypotenuse, 12.50. So again, multiply both sides by 12.50 to solve for AD. So you do that with your calculators, and you find out that length AD is 11.746. All right, so I have one right in here. That's 11.75 centimeters. So we're going to use that length now to figure out the length of side DC. So I've got two angles here. Now it doesn't matter which angle I use, along with the side we just found, to find the length of DC. All right. So if I want to find the length of DC, I could use 55 degrees or I could use 35 degrees. Let's use 35 degrees. And then when we know the opposite side, we're looking for the adjacent side. So I would say the tangent of 35 degrees equals the opposite side, which we just found, 11.746 over the side we're looking for, DC. Recall that if our unknown's in the denominator of this equation, we solve it by this step. DC should equal 11.746 divided by the tangent of 35 degrees. All right. So if you get that, you find out that side length DC is 16.775. All right, so 16.78 centimeters. And the question we were asked is determine the length of BC. So I now know the length of AD, and we just found the length of DC. Therefore, the length for BC should be AD added to DC. So if we do that, we get length of 21.0. I guess if we use the answer is to 3 decimals, 4.275 add 16.775. Work to 3 decimals, and we get exactly 21.05 centimeters. So there's the length of side BC. All right. Let's move on to the next page. 162. Sorry, page 160. A new notation. Often in trigonometry, it's convenient to use the following notation. In triangle ABC, represent the length of the side opposite angle A with lowercase a. So here's angle A. Therefore, lowercase a should be opposite angle A. So that's right here. And the length of the side opposite angle B, well, here's angle B. The side opposite angle B would be lowercase b. And the side opposite angle C should be lowercase c. And if we represent the side lengths like that, then we can write the notation for the sine law. So in every triangle ABC, side A divided by the sine of angle A is the same ratio as side B divided by the sine of angle C, which is the same ratio as side C divided by the sine of angle C. Or we could flip all these ratios, and the same thing's true. Sine A over A is equal to sine B over B, which equals sine C over C. So this is our sine law. You do not have to memorize that. That'll be on your formula sheet. You do have to know how to use it. So here's the proof of the sine law. The diagram shows the triangle ABC placed with base AB on the x-axis. In the diagram, the origin is at A, in diagram 1. The origin is at A, and in diagram 2, the origin is at B. So here's diagram 1. Here's diagram 2. The line CD is drawn perpendicular to AB, and you can tell that's true. They're doing the right angle symbol there. So complete the following work and show that side A over the sine of angle A is equal to side B over the sine of angle B. So in diagram 1, the sine of angle A, which is right here, should equal opposite over hypotenuse. So opposite is CD, hypotenuse is AC. So if we look at that, length AC has been given lowercase letter b, so we change AC into lowercase b. So sine of A is equal to CD over little b, or if I want to solve for CD, we have b times the sine of angle A. If I go over in example 2, which is the exact same triangle, all we did was flip it. If I look at angle B here, and I take the sine of angle B, that's going to equal the opposite side, which is CD, over the hypotenuse, which is BC. Now again, side BC has been given the length A, so I could say CD over lowercase a. And if I want to solve that equation for CD, I multiply both sides by lowercase a, and I get A times the sine of angle B. So it follows then that if CD equals B sine A and CD equals A sine B, then B sine A should equal A sine B. They both equal CD, therefore they should be the same. Dividing both sides by sine A sine B gives the following result. Alright, so if I divide both sides by sine A, and then divide both sides by sine B, we get this equation. Little a over sine A equals little b over sine B, actually. So we don't get that equation. I guess they want us to do it. So we should get b over sine of B equals little a over the sine of angle A. All right. That's what they asked us to prove. That's what we get. Repeating the work above with AC placed on the x-axis will give us the result A over sine A equals C over sine C. Okay. So this is true in every single acute angle triangle. Note, to use the sine law, we need to know 3 pieces of information. You always need to know 3 pieces of information. This information must include both the numerator and denominator of one of the 3 fractions. In other words, we need to know a complete ratio. All right? Need to know a complete ratio. We need to know an angle and the measure of the opposite side. That's a complete ratio. So example 2, triangle ABC from class example 1 is shown again. Use a sine law to calculate the length of BC and compare our answer to what we did in example 1. Alright, so I know this angle is 35 degrees and I know the side opposite that is 12.5. If you use your sine law, that is a complete ratio. This is angle C, therefore this would be lowercase c. I've got a complete ratio there then. We could say that 12.5 over the sine of angle C, which is 35 degrees. That's our complete ratio. So side C over the sine of angle C. Now I'm looking for side BC. I know the angle opposite side BC is 75 degrees. So let's write that in. I'm looking for side BC, or in this case, lowercase a, over the sine of angle A, and angle A is 75 degrees. So I've written an equation with 2 ratios. I know one complete ratio from the work in the triangle. I can use that work to figure out the only unknown value we have, which is A. So I multiply both sides by the sine of 75. So I get 12.5 times the sine of 75 degrees divided by the sine of 35 degrees would equal little side A. So get out your calculators, do that work, see what you come up with. We should get 21.05 centimeters, which is the same answer we had in example 1. Make sure you get that. If you can't, make sure you ask tomorrow in class. Example 3. Use the sine law in the triangle shown to determine the measure of angle ACB to the nearest degree. So they want angle ACB, which is right here. So there's angle ACB. So to find that angle, we need to know the side opposite that. We call that lowercase c. Well, I don't know the length of lowercase c. I do have a complete ratio. I know angle A, which is 110. I know the side opposite angle A, which is 9.4. I do not know angle B, but I know the side opposite angle B, which is 6. So I've got a complete ratio with angle A and side A. I'm looking for angle C, but I don't know side C. However, I do know side B, therefore I could find angle B. So let's find that value. All right. So using our sine law, let's write our complete ratio. We know that side A, 9.4 over the sine of angle A, 110, is equal to side B, 6 over the sine of angle B. So I could write my sine law like that. I know my complete ratio, 9.4 to the sine of 110. I'm looking for angle B, but my unknown's in the denominator. So we could change our sine law around, and there's nothing wrong with doing that, and we could rewrite it as the sine of 110 degrees over 9.4 is equal to the sine of angle B over 6. If I rewrite my sine law, the second equation there, then to solve for angle B is a little simpler. I simply multiply both sides by 6. 6 times the sine of 110 divided by 9.4 will give me the sine of angle B. Now when I do it like this, I should get a ratio, and then I will have to go a second function sine to figure out the angle. So let's make sure we can do that. So on our calculators, we should go 6 times the sine of 110 divided by 9.4. And again, anytime you do trig, you should make sure that it is in degree mode. And then our correct value right now should be 0.599803805. That's the sine of angle B. If I want to find out what angle B is, I must now go second function sine of that value. All right. So angle B should be 36.855847 and so on. So angle B was 36.8 degrees. This question asks us to find ACB, which is actually angle C. So to find angle C, we should say 180 minus 36.8 minus 110. All right. So angle C, if we do that, 33.2 degrees, and it says answer to the nearest degree, so 33 degrees. Example 4. A surveyor measures a baseline PQ to be 440 meters long. He takes measurements of a landmark R from P and Q and finds that angle QPR is 46 degrees and angle PQR is 75. PQR is 75 degrees. So let's label those two things. We also know that length PQ is 440 meters. So let's label that. Calculate the perimeter of triangle PQR to the nearest meter. So I know one length, 440. I want to look for little q and little p, the sides opposite angles P and Q. I'd also like to know the measure of angle R. If I want to find angle R, I know the sum of the angles in the triangle are 180. So to find angle R, I'm going to say that's 180. Subtract 46, subtract 75. So angle R would be 59 degrees. So we need to know that, so now I have a complete ratio. I know angle R, I know the side opposite angle R is 440. So in my complete ratio, I can write 440 over the sine of angle R, which is 59 degrees. So I'm going to use that ratio to find our other two sides. Let's start with P. To find side P then, that would be side P over the sine of angle P, which is 46 degrees. So to solve for P, I should multiply both sides by the sine of 46. So 440 times the sine of 46 degrees divided by the sine of 59 will equal little side P. So again, if you use your calculators, let's figure what that is. So finding side P, we should have 440 times the sine of 46 degrees divided by the sine of 59. And that gives us 369.251. So let's write that in. Side P is 369.251 meters. Now let's do the same thing and find side Q. Alright, so we have our same ratio. We know that 440 over the sine of 59, that's our complete ratio, should equal little side Q divided by the sine of angle Q, and angle Q is 75 degrees. So when I want to solve this one, I multiply both sides by the sine of 75 degrees. So we do that. We get this equation, and that will give us side Q. So again, calculator work. To find Q, we should say 440 times the sine of 75 divided by the sine of 59. And that gives us 495.828. 495.828 meters. And now the question asked us to find the perimeter. So our perimeter should equal side P plus side Q plus side R, which we were told was 440. So let's go to our calculator and figure that out. Alright. So there I have side Q. Let's add that side P, 369.251, plus side R, which was 440. And we should get a 1305.08, and then we'll set to the nearest meter, so 1305. This perimeter is 1305 meters. Excellent. So we use the sine law twice, once to find P, once to find Q, and then we just add that all together to get our perimeter. Add up the sides of the triangle. Alright, you guys have your assignment. Let's get after it.